So looking back at our notes, we've learned how to declare a list. You declare a list by using square braces and listing things between them with commas. And you can mix your data types. They don't all have to be the same data type, unlike some languages. Some languages like C and Java, you can't mix things like this. You can't put words and numbers together in a list. But JavaScript doesn't care. I mean, it cares. It cares how you use the data, but you can store disparate data types in a list. And you can create an empty list if you want. Why would you create an empty list? Well, you might go and add things to that list later. So to print a list, this you don't use very often in your program. But after you've declared a list, you can print it just by sending that list to the print function. List is equal to, 12, and then the word wow, whatever. Then when you do L, it prints it. Or you print L like that, But really, the user doesn't really want to see, data presented in that format. They want it presented in a nice table or something like that. But that's a debug technique for us. To do a better job of printing it, you use a loop. Now, there's more than one way to access data from a list. One is that you can reference it by its element number. And just like in strings, where the first position is called 0 and the second position is called 1, if you want to get the first element out of a list, you can specify it as element number 0. And then if you want to get the element out of the second element out of the list, you can specify it as 1, and so on. So L0, what is that going to be? That's equal to 12. So if you wanted to say, x is equal to L0 minus 12, what's x going to equal? Well, if L0 is equal to 12, and then we subtract 12 from it, what's it going to equal?
0.
Yeah, it's going to equal 0. Because the first value in the list is 12, so then we took that value and we subtracted 12 from it, stored all that into x, and then when we printed x, it was 0. Now the list hasn't changed. That didn't do anything to the list. If you want to change that first element, you can still address it by its position. You can say, okay, I'm going to change that. That's no longer 12, it's going to be 6. Now when we print the list, there we go. If I want to change the second value, I increase that number by 1. So now when I print it, what's it going to print? Well, what's the first element of the list, guys? No one's talking. It's going to be a long class. The second element of the class was wow, but we have reassigned it. What did we assign to it? We assigned 8 to it. So when I print it out, it's going to print
8.
Work with me, guys. 6, 8. Now let's add an element to the list. L.add, and I don't actually think it's add, I think it's append. I'm going to add a new number to the list. Now we have 3 items in the list. Now L.0 is equal to what? It's equal to 6. So L.1 is equal to 8. So what's L.2 going to equal? Yeah. It's equal to the third item in the list. And remember, that's what it looked like when we were dealing with strings. When we did this, name is equal to Joe, and then we printed name 0. We got a J out of it, and when we printed name 1, we got an O out of it, and when we printed name 2, we got an E out of it. Same idea. A list is just like a string of characters in a string, addressed the same way. You can also get a range of characters, just like we did when we had a range of characters in a string. So we're going to say name is equal to Washington. And now I want to find out what the first 4 characters of it are. I could do this. Name, starting with position 0, which is at W, and then going out 4 places. 1, 0, 1, 2, 3, 4. Ew. String indices must be integers. That's because I forgot to use colons. Sorry. Name 0 out to 4 is wash. And the reason that's true is because it goes out to but not including that position. So that's the 0 position, that's the 1 position, that's the 2 position, that's the 3 position, and that's the 4 position. Sounds complicated, but the easy way to think about it is you just take the difference between these 2 numbers, and that's how long the result's going to be. So if I do this, name 1, 3, how many characters long is that string going to be?
3.
It's actually going to be, you take the difference between the 2, so it's 2 characters long starting at position 1, so it's going to be AS. You can, if you're starting at the first place, you can leave that value off. You don't have to type 0 colon, you can just type colon. Now this looks weird and it's not supported in other languages, but it's perfectly valid syntax for Python. What this really means is 0 to 4. And we get wash out of it. So what if we wanted the last 3 characters? Well, let's figure out what position that is. 0, 1, 2, 3, 4, 5, 6, 7. So if I print out name 7, that should be the T. But I also want the O and the N. So I'm going to start at T, and then since I want 3 characters, what's the second number going to be? Excuse me, I'm going to start at 7, and then I want 3 characters, so what's the second number going to be?
10.
Yeah, 10. So that'll spell T-O-N. If you're going to the end of the string, you can leave the second number off. Just like when we started at the beginning of the string, we left the first number off. Name 7 colon means starting at the 7th position and going to the end of the string. And so that doesn't matter, even if the string was twice as long as it was. You know, name is equal to, what's a name longer than Washington? I don't know. Joe Franklin Roberts. Okay. Now if we print name 7 colon, well, it's going to start at the 7th character, 0, 1, 2, 3, 4, 5, 6, 7. It's going to start at the end, and it's going to go all the way to the end because I didn't specify a stopping point. And there we go. All of what I just did is known as slicing. That's only a term used in Python. It's not used in other programming languages. But this takes a slice of that string. It slices that string and gives us that. This also sliced the string and gave us that. This takes an itty-bitty slice of the string and only got the T out of it. Now that our name is Joe Franklin Roberts, if I do this, name, and I start at the first position and then go out 3 characters, it's going to print Joe. That's a slice. If I did name out to 4, it's also going to include that space, because this is starting at the first space, and the difference between 0 and 4 is 4 characters, so it's going to say J-O-E followed by a space. You can do the same thing with lists. I'm going to make a list of data. Books again. Books is equal to, alrighty. Favorite books? I don't know. Jaws. Watership Down. Anybody ever read that? You know, the Thornbirds. I don't know what's popular nowadays. Whatever, you know. Java is easy. Comma, Python is easier. There, now we have like 5 or 6 books in our list. So if I just type books, there's our list of it. So if I want the first element out of the list, I'm going to specify books, parentheses, 0. Print books, square braces, 0. I did start the recorder, did I not?
Yeah.
Good. Alrighty. Now if I want the first 2 of them, I'm going to start at 0. And since I want 2, what's the second number going to be? 2. That'll get JAWS and Watership down. Now what if I want Thornbirds and Java is easy? What is the position of this in the list? Well, if JAWS is 0, then what is Thornbird? Y'all are doing this on purpose.
2.
It's 2. Okay. And I want to get 2 books because I want it to say Thornbirds and Java is easy. So what's the second number going to be if the first one is 2?
3.
Nope. You take the difference between the 2, and that's how many you're going to get.
Oh, so it should be 1, right?
So we're going to start at 2. And if we did 2 and 3, we're going to get 2 of them. Nope. We only get 1 of them because the difference between those is 1. So if we want 2 books, it's going to be books 2:4. Now maybe that seems complicated, but what it's doing is it's going up to but not including the second number. So if I say books 2:4 or 2:4, it's starting at the second book, which is here. So that's position 2, and that's position 3, and then it stops there because it doesn't get up to the second number. It stops one before it. So I'm trying to show y'all 2 different ways to think about it. One is that you can say it starts here and it goes up to but not including that second number. Or you can say it starts there and then you take the difference between the 2. 4 and 2 has got a difference of 2, and so it'll be a list that's 2 items long. So what if I make it print books 1:5? How many books is it going to print? It's going to print 4 books starting at position 1. Which one of these is position 1? Yeah, so it'll be 1, 2, 3, 4. And if we were going to count it out, it's starting at position 1, that's 0, that's 1, and it's going out 2 but not including 5. So it'll get 1, 2, 3, 4. Well, there's not even a 5, so that's great. What would happen if we specified longer than the list was? There is no 0, 1, 2, 3, 4. There is no element 5. But say we tried to get, come on, I don't even need the print statements, and I'm messing up typing it. So if I say books 5, it blows up. List index is out of range. That's because the available choices are 0, 1, 2, 3. Oh, no. Sorry. Let me print the whole list out. 0, 1, 2, 3, and 4. So we could not print books 5. A sneaky way to get the last element, and only the last element, is to use index -1. This does not work in any other language, but Java is very creative. If you say -1, it starts counting backwards from the end. So if I print out books -1, that means give me the last value, which is Python is easier. And if I say print out -2, it's going to go 1 back and print Java is easy. And if I say -2, it's going to say Thornbirds. Now really you don't use this very often, but if you want the last value of a list, saying -2 is a kind of an easy way to do it. So -3, well, that's -1, that's -2, so -3 is Thornbirds. We're going to be able to go out to -4, we're going to be able to go out to -5, but we won't be able to go out to -6. So books -4 is Watership Down. Books -5 will be Jaws. And what will books -6 be? Nothing. It'll be a big fat error. So it's weird that you can do that. And I'm not going to really ask very many questions. I'm not going to take advantage of that. But I do want you to know. Yes, sir.
So can you do the same thing you do from the left, where you say like -2, -4?
Let's find out. Books -2 colon -4. How about -2 comma -1? That works because that's element -2 and that's element -1. Or you could say books -2 and then going out to the end of the list. It's a very good question. I'm just going to copy and paste this entire thing here so I don't lose it later. All right, so that's lists. We've seen strings, we've seen lists. Remember that this is called slicing. Even though our textbook doesn't refer to them as slicing, I think, or maybe that was last semester's textbook. Let's find out if this one does. Go out to our text. All right, I'm going to search for the word slice using this path and see what Google thinks. So I don't know if y'all have done this, but you could tell Google to restrict its search to a specific address. So I want to find the instance of the word slice in the following site, and that site is the path to our book. Let's see if Google finds anything. Okay, chapter 8, the slice operator. All right, so we've gone ahead a little bit. This is chapter 8, but that's cool. So the slice operator, I guess, is that colon between the two braces. So what else can you do with lists? There are some functions that work on lists, especially lists of numbers. There's one called max, there's one called min, there's one called sum. They do about what you would expect. Let's make another list of numbers. Fans of old rock music know this number: 8, 7, 6, 5, 3, 0, 9. There we go. Except I got them backwards. 8, 6, 7, 5. Okay, so there we go. What's the largest number in that list? 9. So if we print out the maximum value of the list, it's going to say 9. Now what's the minimum value of that list? 0, yeah. So if we print out the minimum value of that list, so according to the terminology we've already learned, this is a function. How do we know it's a function? Because it's followed by parentheses. And this is the argument being passed to that function. And then inside that function, this is the parameter. Now notice that we have a function embedded inside of a function here, because that's another function. And L is the argument being passed to that function. So that function runs and calculates, and its return value is then fed in to this function. And you can chain as many function calls like that as you want, but it starts to get hard to read. I don't mind doing like passing one function into another function, but more than that, it gets ridiculous. Okay, so the minimum of that is 0. You could do the same thing with strings, except how it considers less than or greater than is based on alphabet. So let's print out our books again. Now, based on this, which is the highest in the list? Which is the last in the alphabet? Should be that one, Watership Down, because it starts with a W. So the maximum of the books list is Watership Down. Now, what's the minimum going to be? Well, we have two of them that start with J. U, V, W, yeah, so that one's going to be the minimum of the list. There's a sum function. Sum up all those numbers in our Jenny phone number. There we go, 38. You can turn a string into a list if you want to. So let's get a book title. Nah, let's get a song lyric. Lyric is equal to I love rock and roll. Or if you like Weird Al, it's I love Rocky Road. Okay, here we go. Now we're going to split that into a list. Lyric.split breaks that up. So we could store that into a list variable and start processing it. Now this syntax is going to look really goofy. Lyric.split and then tell me the max element in that list. So we're using the return value from the split function. All right, what's the maximum word here? Alphabetically. I think it's going to be rock. Nope, roll. You were right, I was wrong. I did not check the third letter. Very good. What's the minimum? We think it's going to be and. I'm not totally sure it is, because on the ASCII chart, the capital letters occur before the lowercase letters. So let's find out if it's going to be and or I. It's I. Why? Well, back to our old ASCII chart. A capital A is equal to a decimal number of 65, a base number 65. A lowercase a is a 97. So all the uppercase letters are ranked lower than the lowercase letters. Kind of weird, but...
So it goes by that chart, so it's inclusive of like all the symbols too?
Yeah. But that makes me wonder why and was not larger than roll. Oh, because they were lowercase letters. If I'd made that a lowercase I, then it would have behaved as we had expected. So when it's doing this sorting and finding max and minimum, it's using the ASCII values of the letters in order to figure them out. Now, if you're looking at your iPod and you want your songs listed, you don't really want the uppercase letters to be split from the lowercase letters. So programs use a more sophisticated sorting algorithm in order to get that to happen. For one thing, you could just convert everything to uppercase, you know, but... all right, so normally I don't do too much of this business about feeding the function from one into as the argument of another one. If I was going to do this, I would actually split it into two things. I would call this words is equal to lyric.split, and now words is equal to all those words presented in list format, and then I would say, okay, I want the minimum of words. Okay, now I want to write a little program that'll build a list. So I'm going to do new file, save as, save it to my fundamental directory. I'm going to call it list stuff. Okay, so I'm going to create an empty list, and I'm going to call it numbers or scores. We're always talking about scores. Okay, we create an empty list. And then we're going to start adding things to it. We're going to do that with a while loop. While while true. In other words, keep repeating infinitely until we hit a break statement. Let's ask the user for a value, and then let's put that into the list. So x is equal to input, please enter a number, and then add that to our list with append. But I'm going to make it say, or enter -1 to quit. Nah. The word stop is cooler, or stop to quit. Now this isn't very good because it's creating a list of strings. We would need to convert those to numbers. But before we do that, let's check for the word stop. If x is equal to stop, then break out of our list. So that's a keyword we haven't seen before very much. Maybe we've seen it. But what it does is it calls you to break out of the list. And you don't really want to use it too often because it can make the code hard to read. But if your if your list is structured like this as an infinite loop, it would go forever if it didn't ever find a break statement. Then you pretty much know that there is going to be a break statement in there, and so that doesn't make the code too hard to read. Okay, so if x is equal to stop, we break, else we append that value to the score. But we haven't converted it to an int yet. So as part of my else, I'm going to say x is equal to intx. Or instead, better yet, let's make it a float so that they can type in decimal numbers. Now let's print our scores. I broke that statement up into 2 lines so that I can try to get both the shell. But you don't have to do that. Don't break yours up with that end quote plus sign beginning quote. I did that just so I could fit these both in one thing. I don't remember how far I got on my list. Books -2. Okay. There we go. I'm going to close this and rerun it. Okay, please enter a number or stop to quit. All right, 10. It added the value to the list. We don't see that though. We could have printed the list out every single time. That might have been a cool thing to do. 20, 80, you don't have to type the same numbers. 100, -7, -900. Okay, and then stop to quit. There we go. So how would I flowchart something that had a break statement? So now I'm going to try to flowchart this code. Good luck me getting both of these things on the screen at the same time. Maybe we can. We'll give it a shot. So the first thing I need to do, the first statement, is that. But we know that we're going to always start our flowcharts with a little block. It's either going to be a function name, or if it's main, it's just start. You could put a comment there if you wanted to, that this is main. Okay. Now, I'm going to get that scores. Not get that scores. I'm going to declare this. So that's not input output because we're not printing anything and we're not using the input keyword. So I'm going to not use the parallelogram. I'm going to use a square box. And so this will say scores is equal to empty list. Then the next thing I'm going to do is a while loop. And what symbol did I show you in the past that we've used for the while loop?
The diamond.
Yeah, we're going to use the diamond. And we're just going to say while true. I'm even going to put the colon there to make it almost exactly match Python syntax. Now infinite loops like that, you know, a lot of people may not be used to seeing them in flowcharts, but we will be used to seeing them because we're taking this class. So as long as this is true, we're going to do this stuff. The x is equal to input and the if x and all that. I'm going to split this into two things, I think, because it would be too much writing to put into one box. So a print statement is a parallelogram, a tilted rect, and so is the input. So the first thing I'm going to do is this, and it's going to be my print statement that says please enter a number or stop to quit. Print, please enter a number or stop to quit. And that looks really lousy, so I'm going to try to add some breaks, line breaks with the Control Enter key. And I made stop in capital letters. There we go. Stretch it out a little. There. I don't know if y'all are flowcharting along with me. If you are, that's totally cool and great. If you're not, don't sweat it. Here we go. Okay, after I do my print, I'm going to do the input. So usually when I'm coding and I'm getting ready to put it into a flowchart, I break those into two statements. So when I was creating this off the top of my head, I should have done it like that to match what this flowchart is going to be. What's the next statement after my print statement? What is it according to my code?
X is equal to input.
Yeah, it's that one. So, what does an input box look like? The input shape. It's still a parallelogram. Yeah, so this is going to say x is equal to input. I'm going to kind of squeeze it down. I'm going to ignore connecting them with lines for a little bit. Nah, I'm going to do it now. After that, we have an if statement. We know what an if statement is. It's another diamond. Isn't that the teenager slang now? If something is awesome, you say it's diamonds. I don't know. Anyways, here we go. So if x equals the word stop, and I'm going to control enter a break right there in front of the word stop just to make it look like that. And if that's true, we're going to break. Now honestly, I don't know how to flowchart the word break. I'm going to Google it up. how do you flowchart a break statement? Cool. Broken image. Try this one. They just show arrows. I'm not liking that. They have the word break. I can live with that. And they put it in a square box for some reason. So that's what I'll do. That'll be our standard. I guess when I've taught the class previously, I didn't show using the break statement for some reason in a flowchart. So that's break. And then what I'm going to do is I'm going to draw an arrow from break down to the very bottom. But I'll do that at the end of the flowchart. Okay, but if that's not true, else we're going to do this stuff. Now this actually doesn't have to have the else keyword in front of it. Why? Because this stuff is only going to happen if this is not true. There would be no difference to the way the code ran, in this case, if it looked like that. It's kind of like the else is implied, because if you break the loop, then you're not going to execute anything below it. I think I'm going to do that. I think I'm going to leave it like that. That leaves us with no else, so I'm just going to draw the line straight down. If I have an else, I always make it go off to the left. That's my own personal thing. What do we have to do? We have to do the x is equal to float. That's a mathematical operation, so it goes in a square. And then we append it to our list. And that's another mathematical operation. It's not a decision or print. So there we go. Scores.append that value. I'm going to make that a wider box, just to make it purty. Okay. And since this is a loop, we have to draw a line going back up to the while statement. And I make it go to the side like that rather than to the bottom, because typically you think of the line, you know, from an if or a while that goes straight down as being the conditional clause. And then the last thing at the bottom was print scores. So if you break out of the code, well, I'm going to put a little bitty circle down here. That's just a connector, but I want something to hook the line from this break statement up. So here's what our code looks like. And if you break, then the line's going to go from there to there. I'm not liking the way that line looks, so I'm going to turn that into a square, a right angle line. And there we go. Now notice that this is kind of an unusual loop. It's the diamond shape because we're supposed to represent diamonds. We're supposed to represent whiles, diamonds. But there's no way to get out of the loop. So we don't need two lines coming from it. I don't even know if I should be demonstrating this. But the syntax of using a break statement is so important that I do want to flowchart it. The only way out of this flowchart, out of this loop, is to hit that break. Otherwise, it's going to keep repeating forever. So whenever you see a loop that says while true, that's all you're going to see, is the statements going like that. It repeats the entire block of code, then it comes back up to the top. But eventually, it has to find some break statement, or else it's never going to exit. And you don't want that, you know. The user's eventually going to click quit on the menu, or type in -1, or stop, or whatever, to get out of the loop. And then underneath this little connector, I could print the list. Now thinking ahead, I'm going to make the print command a function of its own. So I'm going to call a function called print list. We're going to write that function, and we're going to pass our list to it. And then we'll stop. Let's put our stop box underneath there. Okay, now I didn't do my very best at making this chart as small as possible. I'm going to do that just a little bit. See if we can get more of it on the page at one time. You certainly don't have to do this. It's just because I'm trying to get... Now when you draw your flowcharts, you don't have to go to the trouble that I'm going to make sure that your code lines up this way. The way I have flowcharted this, all of this stuff, scores is equal to 0, and then while, and then print, are in a straight line. They're not indented. So if I look at my code, scores is there, the while is there, and the print is there. So I've tried to line it up so that everything that is not indented is in one line, and everything that is indented is in another line. But you know, if you instead want to make your code go, you know, your arrows go up diagonally and you want to start at the bottom and go to the top or whatever, it's still valid code. What I try to do is write my flowcharts in such a way that it's as easy as possible to code from. And that's kind of a different paradigm than trying to write these flowcharts in a way that you get the most symbols on a page, for example. I wish I could select all the objects and increase their font size at one time. It doesn't seem to let me do that. This may be about the best I can do to compact it. Well, maybe the text is at least readable now if I minimize the toolbar. Not really, huh? There we go. That's about the best I can do to get it to fit on one page. I hope that's readable. Now I want to flowchart this print list function. The print list function is going to take an argument, that's the list, and it's going to print it. But I'm going to, should I flowchart it first or should I program it first? Well, technically you're supposed to flowchart stuff before you program it, but I'm going to program it first. So instead of print, I'm going to write a function called print list. And then I'm going to go and define that function. So now this is our main code, and I put my functions above main, typically. And so I'm going to define something called print list. It's going to take, you know what, I think I'm just going to call it L. That's going to be our list. This variable name does not have to mention this match this parameter name. That may seem weird, but L is just a copy of that. You know, when we pass this in to this parameter, this argument gets copied into that parameter. It's not the original same thing, so that the names can be totally different because this is another variable. Just like if you do this, L is equal to X, like that. They're not the same thing. L is a copy of X. It's like that's a photocopy of X. Same idea. L here is a photocopy of scores. You know. Okay, so I'm just going to use a for statement. I haven't even, I think I did a flow, we talked about fors in the last class. Not today yet. But for every score in L, I think I'm just going to say for every item in L, print the item. And now we're done. Return. Maybe I'll put a print statement above it saying what we're doing. Printing the list. My comment here I may change to loop until break. Because you know it's not really an infinite loop. I'm going to leave that as. Okay. Now let's see if it works. I'm going to run it. Please enter a number, 100. Enter another number, 250, or stop to quit. I'm going to type in a few more numbers. I'm not going to even say them. And then eventually stop. And then it printed the list. There's all of our numbers. And since they're floats, they all end in point 0, or whatever, because we converted into floats right there. Now we could sum them up, to calculate the average or whatever. We can do something with that list, but we have at least created the list. So going back to my flowchart, I want to create a print list function. So I'm going to add another column to my flowchart that has that code. Scroll over here, put a start, except this time my start's going to say print list, def space print list, passing in a parameter called L. There we go. The first thing I do is I have a print statement. So I'm going to use the parallelogram. I use Control-Enter to embed I always waver between putting the parentheses in my print statements and not when I'm flowcharting them. I put that one there. It's perfectly okay to leave them out. But of course, in your code, you can't leave out the parentheses. Now we have a loop. The for loop, we diagram the same thing as the while loop. So we're going to use a diamond. Except this one's going to look more traditional because it's not an infinite loop, so it's going to have 2 lines coming out of it, not just one. So our decision is for item in loop, colon. And now since we're starting a code block here, even though it's only one statement, I'm going to veer off to the right. And I'm going to print that item. It's a print statement, so it's a quadrilateral, a parallelogram. So print the item. And then since it's a loop, we have to have an arrow going back into the diamond. And as I mentioned, I always like it to go diagonally into the diamond rather than straight up or down or something like that. And when the loop is done, we just hit our return statement. And as I showed you the last time we do this, it's certainly not a requirement, but I love to color code my defined procedures, my functions. So I'm going to make this box a nice cheery color. There we go. It's going to be blue. And then I'm going to find the call to that function, and I'm also going to make that blue. Down here. then I could play with themes and resizing everything and stuff like that. But there's our flowchart for our little program. This loop is a data entry loop, and it's a very common way of coding it. If you didn't want to use an infinite loop, then what you have to do is you have to ask for the input first. And then you enter a loop, and you have a second place where you get the input. And I could code that, but I think I will skip coding that today. If you put while true, you have to have a break statement that escapes the loop. Otherwise, if it's a while loop, you know, there's always a line coming back into it, just like on that for loop. So we've seen several control structures. We've seen if statements. They just veer off and then they go straight down. Kind of like that one. We've seen while loops. While loops repeat as long as the condition is true. What is the difference between a while and a for loop? You use a for loop if you know the number of items that you're going to go through, or you know that you will have a set number of items, you know, or you know you will have a range. If you know ahead of time, or the program will know ahead of time that it's going to have a set of data to work on, or that it needs to work on a range of values, a series of values, you use a for loop. If you want it to repeat until a certain condition is no longer true, you use a while loop. And those can kind of overlap. We could write this print code here to use a while loop rather than a for loop. I think I'll skip doing that as well for now. But that's generally the idea. If you know, or the program will know in advance the data that it needs to process, to iterate through, then you use a for loop. Okay, so going back into my shell here, this isn't the actual program, it's just the shell. Everybody's got this program entered, or anybody getting syntax errors they need help with? All right, I believe that on Thursday we also talked about range, but let me make sure. Yes, we did. You use the word range with a for loop when you're going to process through a series of values, like that. What range is actually doing is it's creating a list. We just don't see the list, but we can see the list if we want. So if I go back to my shell and I say x is equal to range 10, then x is now, oh, I lied. Okay, anyways, you treat it as though it is a list of all the values starting at 0 and going up to but not including 10. So when we iterate through it with a for loop, it would print out all the values in that range. For in range, and you don't have to type this, unless it'll burn it in, print in. Stop indenting, and it prints at 0 through 9. So the way it works is if you don't specify a starting point, it assumes 0 as its starting point. And then it goes up to but not including that number. Kind of like when we were doing lists, that second number was a up to but not include point. Same here. So if we made it a x is equal to range, you know, 100, it would count from 0 to 99. If you specify a second number, a first and a second number, you know, then it starts at that first number and goes to the second. So for x in range, starting at 10 and going out to 15, what numbers is it going to print? Well, it's going to start with 10, right? And then it's going to print, well, what's the last one it's going to print? 14, exactly. 10, 11, 12, 13, 14. So you use ranges with while statements. Excuse me, with for statements, not while statements. I don't see a way you could combine the two. So that's a real good illustration of the philosophy of when you use a for statement. You use a for statement when you know in advance the number of values, the range of values, or that you will have a list of elements that you can process. code that into our notes. First, let's copy this program into our notes. I still have 2 copies of it? Alright. Okay, so our rules. When do we use a for loop? When we know in advance the range or sequence of values to process, like a range statement. Or we know that we will have a list of data to process. Otherwise, we use a while loop. When do we use a while loop? When we want the code to repeat until a condition is false. Truth be told, just about everything you program in a for loop, a for loop, you can also do with a while loop. But the syntax is more complicated, and we may as well take advantage of the for loop since we have the syntax. Alright, so we're in the iteration chapter. I think we're just about done with it. Terminology revisited. What is updating a variable? It's when you reassign the variable based on the prior value of the variable. So if you say n plus equals 1, that means add 1 to n and store it back into n. Or here they give n the value of 5, but then they say n is equal to 3 times n. Well, that updates the variable of n. Slightly different than an assignment, but it uses the assignment operator to do it. For loop. Here they knew in advance the data that they were going to process, so they used a for loop rather than a while loop. For f n, and then they gave a list. We recognize that syntax now. Square brace followed by a series of values separated by commas. That's a list. And this says for every item in the list, copy that value of that item into that variable f so that you can do something with it. In this case, it's to build an invitation string, hi plus f, and then print that invitation out. Running through a list is called traversing the list or traversal. I call it iterating. I may call it iterating more often than I call it traversing the list. So in an exam, if I made a question that had traversing the list on it, I would put traversing. Maybe I would put iteration, but I would not put those as 2 different choices and expect you to pick traversing. Alrighty. The while loop. The while loop you use when you don't know the specific number of values, or you don't know that you will have a set range of values or a set list of data. So this while loop will repeat as long as v is not less than or equal to n. Tracing code. I think this will be the last thing we do. Tracing code. Did I do tracing code on Thursday? I don't think so. Tracing code is when you pretend you are the computer and you do the processing by hand, keeping track of the values of the variables. And I'll show you what I mean. I'm going to make a new program. It's going to be very, very simple. It's going to have a piece of code called halvesies. So halvesies. Define halvesies. And it takes a parameter. Now what it does is it has a while loop. While n is greater than or equal to 1, then print n and you don't have to type this one in. Print n, and then n is equal to n divided by 2. That's an update the variable. And then when we're done with that, return. So down here inside of main, I'm going to call halvesies. And I'm going to call halvesies with the value of 16. I'm going to change this to floor division so that it's always an integer, so to round down. Alrighty. If this program works, here's how it's going to work. I may have a syntax error. Oh, really? Okay. So I call halvesies 16. So by the time we're in here, n is equal to 16. And now we're going to print something. Changing the code, sorry. I'm going to create a second variable called sum. It's going to start off at 0. And then each time we do this, we're going to add the value of n to the sum. Just so that we have something else to do. So we have 2 variables to track. So we're going to make a little table. N and sum. Sum gets initialized with 0, and n gets initialized with a value that's copied in. Okay, so we step into it. While n is greater than or equal to 1. Is n greater than or equal to 1?
No.
It equals 16, so sure is. So what's the next thing we do? We add n to the value of sum. So sum now becomes 16. N gets divided by 2. N divided by 2 stored back into n. N is now equal to 8. So we've completed one iteration. Now we go back up to the while statement. Is n greater than or equal to 1?
Yes.
It sure is, because it's equal to 8. So we add 8 to 16, and we get 24. We've done that. Now we're going to print n. Now we're going to calculate the new value of n. What's the new value of n? It's 4. N is equal to n divided by 2. There we go. Now we loop again. Is n greater than or equal to 1?
Yeah.
Sure is. So sum is plus equal to n. 24 plus 4 is equal to 28. We divide n by 2, so n becomes 2. And then we loop. Is 2 greater than 1? Yep. So we add 2 to sum. Sum becomes 30. We have n becomes 1. Now is n greater than or equal to 1? Yeah, it sure is, but this is going to be the last time we go through the loop. So we add 1 to the value of sum. 1 divided by 2, rounded down, is 0. So n is now equal to 0. We go up to the while loop. Is n greater than 1? Greater than or equal to 1? Nope. So what do? We bail out of the loop. The loop condition is no longer true, so we fall through and we return sum. So when we do this, if we did our tracing right, and I print out sum, then sum should be equal to that number that I just wrote up there. Assuming the syntax is all correct and everything, I'm going to call this halvesies. All right, and the sum was equal to 31. Is that what I said it was going to equal? Yeah. Okay. You can't see that. Now you can. Still not? Come on. I know I need to lower the thing, but okay. So I traced it and I accurately got the value. Now usually you don't do that, you know. Why do we buy a computer? So it'll do all that. You can see that it's very slow and I could have made mistakes. Last time I taught this class, yesterday, I did make a mistake in my tracing and I had to go back and I had to correct it. So, you know, it's fraught with errors. But if you're trying to figure out what's wrong with your algorithm, that's a good thing to do if you can't figure out why you're not getting the answer that you want. The other thing you could do when you can't figure out what's wrong is you just print everything. I could print the value of sum each and every time, and I could watch it go. You know, that's called adding debug print statements. All right, we're done. I'll see y'all on Thursday. Go ahead and upload. I forgot to create a Dropbox. If you made a flowchart, upload the flowchart. If you didn't, that's totally cool. Go ahead and upload the PY script. So it's going to be Dropbox M. All right, refresh your Dropbox, you'll see M. It put it in the wrong thing. Doesn't matter. Scroll down to the bottom, you'll see it. Now it's in the right folder. Okay.